Okay, this is a quick video about how to do the maximum power part of the current lab. Now, everything you've done to date with LTSpice has required that you set a specific value for voltage and resistance and capacitance, as we'll see shortly. However, with the maximum power part of the current lab, you need to make R1, the load resistance, as a parameterized resistor value. So in order to do that, you can see that here on R1, and it's a bit hard to see, but it's basically setting up the resistor value, the value of resistor R1 as a parameter, and you do that by saying open curly brace R close curly brace, where R is the variable you're going to use, and then you need to do a .step spice directive to tell LTSpice how to vary the parameter R. So .step param R, that says vary the parameter R, and I think it's saying in steps of from 0.1 of an ohm up to 2000 ohms in steps of 100 ohms. That's what the three numbers there are. And if you run that, it's actually what it actually puts out to start with is it doesn't do what I have on the screen now, right? It currently the value I've selected is the voltage at node 2, which is the voltage at the top of resistor 1. But what we want to do is we want to edit that and multiply the voltage at the top of resistor 1 by the current through resistor 1, and that'll get us the power. If we do that, then the thing we get plotted is the power dissipated in resistor 1, and you'll notice that the x-axis now is no longer time, but it's the change in R value, in the value of resistor 1. And you should get a plot something like that, right? And because we know that the maximum power transfer theorem is says that the maximum power is dissipated in the load when the load resistor equals the Thevenin voltage, sorry, the Thevenin resistance, then we should get a peak in the power at 1000 ohms, and sure enough we do. I can go in here and change that. Let's change it to 1500 ohms and then stop that and rerun it, and you should see that the value, the peak now changes to be at about 1500 ohms. Or if I change R2 to be 250 and rerun it, I change the position of the peak to be at about 250 ohms. Okay, that's a quick run through about how to use LTSpice to plot the power dissipated in the load so we can look at the maximum power transfer theorem.